I'm here by the canal, and I think this is a really good opportunity to start talking about music theory, but from a physics perspective, which is my passion. So I'm gonna talk about harmonics, which is the fundamental understanding we need to have as musicians to comprehend the reasoning behind all theory. Okay, and many people just skip this part. Many teachers just think like theory is theory and you have to understand it like musically, and that's what makes a good musician. And that's true in a way. Like knowing the physics is not necessarily going to make you a better musician, but it's useful, because then we understand that things come from a place. They're not like made out of thin air, which is a funny choice of words, because they actually are made of thin air. The waves that propagate sound travel through air, so basically air is our medium. Okay, and since we're talking about waves, they have the same behavior, whatever the medium. So we can talk about waves in water, and we can see in this picture here that I'm showing a very good representation of atmospheric waves. Okay, so waves in the air. But what we're seeing is like a cut in a slice of air. Okay, so the surface of the water would be this cut where we are making this slice of air, and the parts where the waves are higher is the peak of pressure. Okay, in three-dimensional space, which is the medium we are working with, the atmosphere is three-dimensional, right? Instead of having higher and lower waves, we have higher and lower pressure area zones. Okay, so zones of higher pressure and zones of smaller pressure, and those zones of higher pressure is what is traveling in the form of a pulse. Okay, so for example, when we hear La, we are actually receiving 440 approximately, right? Depends on your tuning system, but anyway, that's a talk for a later video. But let's stick to the 440 for now, and basically what you are hearing is 440 pulses. That is areas of high pressure reaching your ear. Okay, so when an area of high pressure travels through air, it's like the molecules are bouncing against each other and producing this pocket of high pressure zone, and it excitates membrane, our tympani, right? And that moves a little bone, which is the three smallest bones in our bodies, that works like a hammer, and that hammer translates the waves into electrical signals to our brain. So 440 little pulses like that are gonna result in our experience of hearing a La sound. Now to the image. Okay, we are going to draw a line where we can see the most clear waves, right? So I'm gonna use the red, and we're gonna go like a left to right. Okay, so you can see here, like there is a wave here, right? We can actually use this line here to understand exactly where the waves are. So there is a little perspective going on, but you can see there are like these big valleys here, right? So the way light reflects on the surface of the water indicates how the angle of the surface of the water is positioned when I took the photo, and that is correlated with the waves height, right? So now I'm gonna use the next line and a thinner line, and I'm gonna zoom in, and we're gonna notice that, oh, there is a weird blue line there. Anyways, we're gonna notice that there is like these smaller waves here, and those in music are kind of what we call the harmonics. Okay, so waves within waves, and the resulting pattern here is the sum of all those waves put together. We call it constructive interference when they are both positive, and destructive interference when they are on opposite signs. So a wave that is high interacts with a wave that is low, so they become like closer to zero. And we also would call constructive interference when they're both negative, but that is the same as saying they're both positive, because the wave oscillates up and down. So if they are equal in sign, it means they will be equal both positively and negatively, okay? Meaning like low pressure zones are going to coincide with, and high pressure zones are also going to coincide, okay? So this is in phase. When they're out of phase, it's the opposite. So the high peak will coincide with the low peak of the other wave, and they'll destroy each other. Okay, so let's go to the next layer. We can see all this little, oops, let me thin this a bit, the thinner one. Like, you can see like those really small granular waves, right? Those would be like the higher harmonics. And now you can visualize how the harmonics work in atmosphere to create the sounds that we hear, and what this will ultimately result in. Even before we start talking about theory, what this is going to result in is your signature timbre. Okay, so how your voice sounds is a reflection of how intense each one of these harmonics are in your voice. And depending on your biological structure, and also for instruments it's the same, depending on the kind of wood that you use to make your guitar, depending on the length and proportions of your flute, the harmonics might even change. They are not always the same, but we work with the harmonics for a string or a tube. You know, there is like a perfect ratio that in music we found that works really well, and that ratio is when you reach the first harmonics on an octave, second harmonics on a fifth, and the fourth harmonics on a second octave, and so on. It goes on. We'll talk more about this in the next video. I hope you enjoyed it, and next time you look at the surface of the water, try to visualize sound waves on the water. I hope you enjoyed. Goodbye.